And what they decided they needed to do was to restart all of S3. And at that point in time, never restarted all of S3.
Welcome back to the Pro Tech Show. Today we're joined by Rich Burroughs, who hosts the Kubernetes podcast, the Kube Cuddle. Now, the original intention for this video was to be a chat about Kubernetes, but we decided to take a detour because Rich's career path from traditional sysadmin to automation magician is an interesting one that I think will appeal to a lot of you guys. Let's bring him on. Hi Rich, welcome to the show.
Hey, thanks a lot. It's really great to be here.
So, just by way of a quick introduction, Kubernetes is the world you live in right now, but you didn't start there, did you? And that's what I think is something that's probably going to be quite interesting to people who watch this channel. So you started out as a more of a traditional sysadmin, isn't that right?
Yeah, so I was one of those people who was really into Linux very early on. So I started off using Linux when you would download images for like 20 floppy disks and use this program called rawwrite.exe and write those out to floppy disks. And that's how you would install Linux. And so it was a hobby of mine for several years. And then I got a really entry-level job at a sysad at an internet provider in like 1995. I was just like taking people's phone calls, like setting their modem and init strings and stuff. And my boss realized that I knew a lot about Linux, just because I'd been playing around with it. And they didn't have a sysadmin at the time. The previous one had gotten fired. There was nobody patching the systems. It was the Wild West. So yeah, like I said, this was about 95. I was there for about 3 years. I then went to work at WebMD. And at that point in time, it was definitely one of the premier destinations on the internet.
Yeah, I think even today we've all heard of it.
Yeah, I mean, most people would have heard of it, but I think it was even bigger relatively back then, And the company was, the stock analysts were saying, oh, this is going to be the Microsoft of healthcare. And it was just huge. They were taking out Super Bowl ads and stuff. And at that point in time, I became the guy who deployed the WebMD.com site. And
right.
Yeah, and back then...
That wasn't the one where someone got fired, was it?
What's that?
That wasn't the one where someone got fired and you were left just holding the bag, were you?
No, it wasn't that. It was more like...
Okay.
They moved me up in responsibilities as they gained trust in me. It was more that. But I've been in that other situation too, for sure. That happened later in my career. But no, it's really funny because you think about the way that we operate software nowadays and how much, we build in for reliability, how much redundancy there is. Back then, it was actually really before horizontal scaling took off. And so the model back then was you would buy these giant Sun servers that ran, so was it Solaris? I think it was still Sonos at that time. And
it's going by.
They had redundancy in the chassis. So there would be these trays with CPUs that you could pull out and hot swap, while the thing was running. It was just a whole different world. And there were 3 of these big machines. And I would take one out of the load balancer. I would run some scripts on it to deploy the code. That would get done. I'd put that one back in service and then move on to the next one. And we would do that for all 3 servers that were taking all this traffic. And it's just crazy to look back on that now because so much has changed.
It is mad to think somewhere like WebMD had 3 servers. I mean, I've got more than that in my house, for crying out loud.
Yeah, I mean, that was just the front end. There were a few more, but yeah, that was taking all the traffic for, one of the most popular sites on the internet.
That definitely wasn't using Kubernetes then. I mean, it's a little bit before that, I'm assuming, in time frames, but you say 95.
Yeah. Yeah, this was more like 98 to 2000 when I was there. I did start off as a sysadmin building servers, but I moved into the situation where I was more responsible for just that, application part of the stack. And then that kind of led me a few years later into getting into using Puppet.
Right. So was this the start of your automation journey then?
Yeah. So, there was, I moved on to another job. It was a startup. We ended up getting acquired a few years later by this really big company. And some of the folks were using Puppet to just, build the servers and all of that kind of stuff. So they were using it more for like those traditional sysadmin tasks. But we ended up using it later for the app configurations too. And that was where I came into play because I was like the person who kind of owned that. And it was a lot of, templating. It was this sort of Ruby-ish templating where you're, filling in information from like this internal database that Puppet has. So I started off doing these app configs, and then actually the thing that you're talking about happened, which is that like the two guys who built all this stuff out ended up leaving and going to other companies. And so one day I was like the Puppet guy, right? And so they sent me to training. I went to the Puppet office for a few days. It was a pretty amazing experience. There were so many like smart, kind people there. I just really enjoyed the kind of like internal community they had at the company, and it just totally re-energized me. Like it was like this whole new world opened up,
If everyone just left and you were left holding the bag, I mean, that could have gone one of two ways really, but it's a good thing that you were up for the challenge, definitely. It's amazing how often that happens in our area. Like in IT, you hear about that so many times, and I can't go into details about it, but I've experienced something which was a little bit crazy, where turned up one day and the next day half the IT department didn't turn up. They just went AWOL.
Oh, wow.
It's amazing. I think we've all got stories of hearing stuff like that happening.
This wasn't quite that drastic. Like one guy left and then the other one did, but they did prepare me pretty well. And the nice thing about it with a tool like Puppet is that it's code, right? I didn't necessarily understand all of the code at first, and I didn't know the code base as well as the people who'd set it up, but like you can figure it out, and I think that we did actually get a little bit of help from, the folks there at Puppet. I then worked, in another job where I was brought in to set Puppet up from scratch, as opposed to like continuing what these people had done. I was like setting up a whole new kind of greenfield like Puppet environment. And then I went on from there to actually work at Puppet. And so I was an SRE.
Oh, okay. She really went for it.
Yeah, so I was an SRE running Puppet internally.
Yeah, that's an interesting move. It might be worth chatting about that SRE side of things. I don't know if this tallies with your experience, but when it comes to DevOps, it's supposed to be dev and ops and the merging of the two. But I find that quite often it's usually a developer that's pushing the whole thing.
Yeah.
I've never worked somewhere that did formal SRE, although I think one or two of the teams are possibly informally going down that route. But the way it's always kind of in my head been is SRE is like DevOps if it was implemented by an infrastructure person. Is that a fair assessment, or how would you describe it?
I think it's a super fair assessment. If you look at the Google SRE book, they describe in there how they started the program. And that was the initial conception of it, is that it's infrastructure, it's engineers who are working on infrastructure, right? And so it definitely has more of that sort of traditional ops feel to it. I did work at one place where there was a DevOps team, and it was embedded inside the engineering team, so it didn't have any ops people in it.
Right. Okay.
So it's funny how these things happen. Like, the way you have an idea of what this word means, but then the way that it's actually implemented at companies can be completely different. And it's the same way with SRE. Like more and more teams now are doing SRE, but what they think SRE is not necessarily the same thing as what Google is. And it shouldn't be, right? Because they're not Google. And most teams don't have the problems that Google has. So we don't want to just like read those books and do exactly what's in them, because a lot of those things, like most teams don't have the kind of scale problems and things like that Google does. So, but I think that like usually the assumption is that an SRE role is going to require more actual engineering than a DevOps role. When I think of DevOps roles, I tend to think of people who are like maintaining CI/CD pipelines, and building infrastructure and doing things like that. Whereas an SRE, is also going to be doing those things and working a lot on automation, but they may also be fixing bugs in the application that they run into, right? That they may be doing that themselves as opposed to like kicking that back to the application engineering team and telling them to fix it.
Okay, I mean, that makes a lot of sense. I think it's a good point you make about just because Google came up with the SRE doesn't mean that you need to do it like Google does. I mean, that applies to a few things, doesn't it? You know, I don't know if you've had the pleasure of sitting in things like Prince 2 courses, and it's all a bit dry and very, very big and feels a bit over the top, and you always take stuff from that and then you apply it to your situation. You don't just go the whole hog, or you'll end up spending an awful lot of effort and stuff that doesn't actually matter for you.
Yeah, absolutely. And these are things that go way back. Like one funny example to me is Agile, you know, the framework for developing software. If you go back and you read the Agile manifesto, it's very much talking about building a better way for your team to work the way that you want to work, right? It's not prescriptive. It doesn't say you need to do X, Y, and Z to be Agile. But we've come to this point now where there's all these people who they have these Agile certifications and they're super dogmatic about what they think Agile means. And like, if you don't have this retrospective meeting, you're not Agile, you know, and it's completely turned around from what was intended in the beginning. So it's funny how this stuff happens, you know, and I think it's sort of similar with DevOps too, that, you know, if you look back at when DevOps started, the thing that they were trying to address was this sort of schism that was there, and it was very real. Like I was working back then in, again, you know, because of that role that I had where I was like that application administrator, I worked really, really closely with the application engineers, right? Because I was, you know, the one who was taking their stuff and putting it into the staging environments and deploying it to production. And so I worked closer with them than most of the people on our team. And what was happening was that these teams were incentivized to do things that were kind of in conflict with each other. So you've got an engineering team and they're incentivized to ship, right? They want to ship fast. They want to ship lots of stuff. At the end of the quarter, people are going to look at how much stuff they shipped, and that's how they're going to be judged on whether they did well or not. And you've got an operations team who's getting judged on things like stability, right? And like, you know, how many nines they got and security and things like that. And if you're shipping too fast, if you're not taking the time to do things the right way, you could very well be causing problems that are going to be security problems or stability problems. And so it's like these teams were like incentivized to do these things that were almost directly in conflict. And that's really where DevOps came from, is like, what can we do to make people work together and do this process in a way where we're kind of all on the same team. We're not, you know, these two different teams fighting each other all the time. And now we've come to this point in time where if you ask some people what DevOps is, they will tell you that it's basically a CI/CD pipeline, right? like they will maybe even name a specific tool that they think is like the DevOps tool, and that's how you do DevOps.
And there's literally tools called DevOps in their name.
Yeah, so it's come clear around, and I think that this sort of thing is like, you know, almost certain to happen. And I think that if there are people who push back, you know, and I will do this from time to time, I'll explain, like I just did, you know, where DevOps came from and what it's supposed to mean. But the reality is I can't control how other people use that word, right?
Yeah, I do have a feeling that's how it started with the idea, and then how it often gets implemented is developers going, wait, we could use this to cut out the ops guys and just ship our code.
Like I said, I did work at a shop that was literally had the DevOps team that was inside of engineering, and that was actually the place that I had been brought on to do the Greenfield Puppet thing, and that was I was led to believe that everybody was on board with how we were going to implement Puppet, and I showed up, and it turns out that the ops people were, and the application engineers were not. And it was literally ops versus engineering, right? Because something happened where like there was some question about like who was wrong or who caused this problem. It was everybody reported up. Yeah, exactly. People pointing the fingers at the other way. And
it's funny how often technology problems aren't actually technical in nature. It's, you know, where we've got people involved, people will do people things.
Yeah, absolutely. And there were massive culture problems at that place too. People were scared. Like, I don't know if you've ever worked at a shop like this where people are literally afraid of, like, if I cause a problem that's big enough, if I take the site down or, I cause a big outage, I'm going to lose my job, and
I've not worked for someone like that. The company I work for is really good actually, but I've worked at a customer like that, and I was in a bit of an envious position because I could just go in and, they go, if blah, 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 then you'll get fired. They'd be like, how? You don't employ me. So I was in quite an envious position compared to their guys who did just fear for their jobs every day. It was horrible.
For folks watching, if you've heard about, blameless cultures, that's something to look into if it's a phrase that you're not familiar with. The idea is that we're working on these things as a team. It's not just like necessarily one person's fault if something goes wrong, if there is an outage. But beyond that, there's an even kind of bigger view, which is that these are what people refer to as socio-technical systems, right? So like when you're operating software, the software should really protect you from doing that terrible thing that's going to take everything down, right? Really, really good example of this is the big AWS S3 outage, which I think was like 2017. That was a situation where, there was an operator and they were typing a command to do something to like take some of the servers out of service, I think. And they typed the wrong thing and they ended up really breaking things badly. And it was really interesting at that point in time to look at the reactions to that on Twitter, because there were a lot of people who were like, oh, that person's an idiot, they deserve to be fired. And there were a lot of other people who were like, why was that person able to type a command that took like all of the servers out of service? Like, how was that even possible, right? And so I think that really goes along with this idea of the blameless culture is the fact that these are very complex systems. There's people in the systems as well as software. We can't ignore the people. They're very important. And when an outage or a problem like that happens, really the thing to do is to try to understand why it happened, and not just like jump to these quick conclusions and blame people.
I mean, if your resilience plan relies on nobody ever making a mistake, then you don't have a very good plan.
Absolutely. We're all human beings, and that's going to happen for sure. And there's some really smart folks in that field. The people at Netflix, they do a really good job with this stuff, probably more advanced than a lot of shops where they actually investigate some of the incidents afterwards. They'll interview the people involved and try to understand what happened. And I think that's a really good thing to do if you want to improve the systems.
They deliberately cause some of their problems, don't they? Don't they practice chaos engineering?
They do. So this is a subject I actually know a bit about. I worked for a few years ago at a company that has a chaos engineering like SaaS, that's interesting. So that's kind of their product.
It's something I keep thinking I need to do a video about, but it's not something I've got a lot of experience with, but it sounds like fun, and maybe it just appeals to the inner anarchist or something. But the idea of deliberately thinking of ways to break your systems, it's like flipping the sysadmin role on its head. Is it as fun as it sounds, or is it like, cybersecurity that sounds fun but is really a lot of logs and procedures?
I think it's definitely more fun probably than cybersecurity is. I can explain it to folks team. I can explain it to folks on a high level. For those of you who maybe aren't familiar with it, the idea with chaos engineering is another phrase that people use for it sometimes is failure injection, right? So it's this idea that you've got a system and you're going to, in a controlled way, inject a failure into it and see how it responds. Back in the old days, before this sort of stuff really existed, we would set up infrastructure and we would test things, like sometimes manually, like you'd take one of the servers out of service and see if the other ones take the traffic or whatever. It wasn't necessarily a new idea. I think the new part of it was more about automating it, which is what Netflix did. They built this tool called Chaos Monkey that would just randomly nuke servers, right? So it would this was the point in time where they were moving over to AWS, and it would just shut down EC2 instances randomly. There's a lot of different kinds of failures you can inject now with the tools nowadays. The approach that you take generally is using the scientific method. The idea is that you have in your head like a hypothesis about what's going to happen, right? Like I'm going to take this thing down. I think our service should be resilient to that because of X, Y, and Z. And then you really do that. You really carry it out. And some people do this stuff in production. It doesn't have to be in a production environment. It could be in any environment, right? It could be
isn't that the way the Netflix do it? They do it actually in production and see what happens. But within bounds, like it's not like they just kill all of Netflix for a laugh. They might kill a little bit of it, but then quickly reroute the traffic.
Yeah, and when I worked at that company, it's a company called Gremlin. When I was there, there were a lot of people who were definitely resistant to like doing this stuff in production, and you don't have to. It could be a staging environment. There's lots of different ways that you can do it. The advantage to doing it in production, though, is that that's where you're really making your money, right? Like your staging environment probably isn't set up the same way. It's probably not as resilient or robust, and so. Or if, like, say there's a configuration problem of some sort, that ends up causing an issue, like it might be okay in staging and it might be misconfigured in production, right? And so really, I think that like the end goal should be to do the stuff in the production environment if you can get away with it. But it can be a hard sell, and a lot of people are really kind of reticent to go there. But the idea isn't to break anything, right? Like the idea. Like you don't do a test if you think that you're going to cause an outage, right? That's not at all the point of it.
Like the test really I was right.
Yeah. The test really should be things that you think are going to be okay, right? Like I think I could take this thing down and everything's going to be fine. A lot of people, especially folks who've been in the industry for a while, have probably experienced that situation where, something breaks and other things break because of it that you didn't expect, right? People use this phrase, hidden dependencies, which happens a lot where there's a microservice and somebody makes one of its other services, one of the other services use that first service's API, but somehow that's sort of a secret, right? Like it's not known that happened, and that service A breaks and suddenly the other one does too. And that's one of the things that I think the chaos engineering is really good for, is like kind of surfacing those sort of hidden problems, those things that are either misconfigured or dependencies you don't know about, stuff like that.
I vividly remember spending ages testing something in a lab environment and deploying it into production. And it went perfectly every test in the lab. And it went in production, it fell over in the first run. And it was because there was a WAN link in between that dropped for 2 seconds. And that was enough to cause a test to fail. And because the test failed, it went, and basically rolled back all of the changes. So spent about 7 hours making loads of changes, then thought it had failed because a test failed, and it rolled all back. Whereas if it just tried again, it would have been fine. But I wasted an entire day just watching it go and come all the way back again.
That's really funny.
And it's because in the lab, I didn't have an unreliable WAN link.
Yeah, absolutely.
I had WAN links simulated, but I didn't simulate the fact that they can go down.
Yeah. And yeah, these things happen all the time. And, I mentioned earlier that S3 outage when the, operator mistyped the command. Well, if AWS published a really detailed, like kind of postmortem retrospective, whatever you want to call it, about that incident. And when you read through it, you go through the timeline, that wasn't actually the big problem, right? So they recognized what happened pretty early on, and what they decided they needed to do was to restart all of S3. And at that point in time, they never restarted all of S3. They had done like bits and pieces of it, but they had never restarted the whole thing at once. Yeah, so it ended up taking hours and hours. And if you look at the timeline of the outage, the vast majority of the time was this period where they were just trying to restart S3. And because they'd never done it, they had no idea it was going to take that long.
Oh, dear. Oh, I didn't know that. It's not the time you want to be trying a new thing. Have you ever done this before? No. But, when things are broken, that's the time to test it out. Oh. So how did you get from, you were doing sysadmin, then you went across and you started learning Puppet, then you worked for Puppet, and you were doing some chaos engineering at one point as well. How'd you get from that to running a Kubernetes podcast?
In terms of Kubernetes specifically, I got interested in it back in, I think it was like 2015. It was pretty early on. I saw Kelsey Hightower, who a lot of people are probably familiar with at that point. So he's at Google now and he's been there for a while, but he started off working at CoreOS, one of the Kubernetes vendors at the time. He did this talk where he was like playing Tetris, and he used that as sort of a metaphor to like explain Kubernetes. The idea being that we have these workloads we want to run, right? And in the old days, and this is definitely what we used to do where I worked, we'd provision a server, and we'd pick which services are going to run on it, right? It might just be one service from the microservices stack, or it might be several, but you figure out how many servers you need, you figure out what apps are going to run where. You want to provision a new service that just got written and there's not enough room on the server, so you have to like buy another server and get that set up, right? And that was kind of the old days. These infrastructures were very static. They didn't change very often. And when they did change, it usually involved a lot of work, from people to get that done, like spreadsheets of like what applications are running on what servers, And the thing that Kelsey mentioned is that, Kubernetes had this promise to really change the way we look at that. So, if you're running especially stateless workloads on Kubernetes, it really can be pretty much that way. You can have a bunch of, the Kubernetes compute nodes, and you don't have to think about like, which apps are running where. The scheduler does that for you, and so you start to look at these hosts, and like instead of thinking of them as hosts, you start to think of them as like collections of CPU and memory, and storage. And so all these resources, are now like, they're not tied to like, one specific node as much, because the scheduler does so much of that logic for us. And so that was my initial like sort of introduction into Kubernetes. And the way that Kelsey puts it, and I totally agree with this, is that in the old days, like we were the schedulers. And like I mentioned, I specifically, having been in that role as this, application administrator, that was part of my job. I was that person who knew what service ran on what server. So the promise of this world where we didn't have to worry about those things anymore really, really attracted me. And the more I looked into Kubernetes, the more it seemed to me like it was just automating a lot of the patterns that we were using in infrastructure already. So if you look at something like the readiness probes and the liveness probes, like when an app comes up, you don't want to start sending traffic to it until it's really ready to receive that traffic. And we used to do that, before Kubernetes. We managed to like automate this thing with our Cisco load balancers, where it would do kind of the same thing, right? The load balancers, would return the state of the app, but we had to invent all of that, right? Like we had to design how to do that. We had to like read the Cisco docs and figure out what the load balancer API needed and all of that kind of stuff. And suddenly with Kubernetes, you had that just built in. It's just there. And just the automation of doing things like the service is unhealthy, like I'm going to restart it. I'm going to deploy a new container or whatever, like those are the kinds of things that I used to do. I was that person who restarted the app when it died in the middle of the night because PagerDuty called me. I'm definitely someone who likes embracing the newer technologies. With almost every technical decision, there's trade-offs, and you just need to evaluate what's going to work best for you. And as much as I love Kubernetes, it's not the right tool for everything,
Yeah, I mean, that's what it is. It's the right tool for the job, isn't it? Sometimes it's containers, sometimes it's virtual servers, sometimes it might even be physical servers for some reason, but there's never one size fits all. So on that note, what sort of downsides would you say you've come across when it comes to stuff like Kubernetes? Is there anything to watch out for when doing that?
You have to be thoughtful about upgrading, There are sometimes API deprecations and things like that. And so usually they'll do things like they'll put a deprecation warning in the logs like a couple releases before they actually kill that API. But I think that in practice, one of the things that's the hardest is this idea of multitenancy, because Kubernetes really wasn't built for it. It really wasn't built to have shared a shared cluster that was super secure, at the same time. It was pretty wide open. And the Unixes were in the early days, like if you look at the stories way back in the day about the kinds of stuff that people would pull on Unix servers and Linux servers early on. But there's this problem with sharing clusters, and clusters have these namespaces, and one of the models is that you give an individual or a team a namespace and they use that, and then the other model is you kind of give everybody their own clusters. And both of those have problems. The namespace isolation, the problem there is that people sometimes want to access global objects that aren't in a namespace. And so if you only give them access to a namespace, they can't do that. And then on the other side, you've got, 1,000 clusters running who knows what, and it's just a management nightmare. And so I think that's an issue that a lot of people are dealing with right now. Where I work, we actually make this, created this open source tool that's called vcluster. So it's like the letter V and then cluster. That's really cool because it allows you to sort of create like a virtual cluster inside a namespace. So it looks to the person who's using it like it's a full-blown Kubernetes cluster, but it just runs inside a namespace. So you kind of get the best of both worlds. You can share a cluster, but it feels to people like it's their own thing.
So it's not like a cluster within a cluster.
Yes, exactly.
I feel like if there was a film made about this, it would involve Leonardo DiCaprio and a spinning top.
So it's funny that you mentioned that because I actually made a video that's called vCluster Inception. So if you want to Google for that, it's on our YouTube. And what I did is I had a virtual cluster running inside a real cluster, and then I made another virtual cluster inside of the one that's there, right? So right. I had a virtual cluster running inside a virtual cluster running inside a real cluster.
Nested cluster virtualization.
Yep.
So what was the use case for that other than just making a video? Was it just because you could?
Just because you could. I mean, people may come up with a use case at some point, but yeah, it's. I think that's one of the big problems. We also focus a lot on self-service, which I think is really important. You really want to give developers a way to be able to like get their own dev environment. If it is on a shared cluster, you want them to be able to like provision their own namespaces and have be able to do that on their own instead of having to open up a ticket, for someone. I ran into this when I was doing ops, right? From both sides. So I would be the person that the engineers were waiting on because they needed something and they opened a ticket and it got assigned to me. And so I was the one who was blocking them. But I also would open up a ticket for the firewall team, or I would open a ticket up to get a cert installed or whatever it was, a load balancer. And I was waiting on someone else. And so to me, that got drilled into me, years ago that self-service is really one of the biggest things you can do in terms of like, helping, a team's velocity. And it helps with people's happiness too, because like nobody wants to be in that position where you're blocked and you can't do the thing that you've got to do. It's not fun to be sitting around waiting for days. You're complaining about, that other team that's ignoring you and trying to escalate to your manager and who's going to escalate to their manager and all this stuff, and if you can give people a way to do their jobs without having to, ask someone else for help, then, it makes everybody like, faster at doing what they need to do and happier too.
Definitely had that. How long does this take to do? 5 minutes. After the guys in America wake up in 7 hours time.
Yeah, the time zones thing, that brings it even more into play if you're on really distributed teams.
Our lot are distributed between the UK and Australia, but that's not actually as bad as it sounds. For some reason, it's harder to work, I think, with America than Australia, because in Australia, like when you're awake, they're asleep, like, so you have to plan around it. Whereas in America, because you can chat to people, like we're chatting now, and there's no problem. But then I realize, okay, but it's like still early afternoon for you, and I'm getting ready for bed. so
yeah, exactly.
If you've got a request in an hour's time, I'm going to be asleep. So what's the point? I think, looking at the clock, you probably need to get back to work now because it is bedtime for me, but you've got a job to do, unfortunately.
Yeah. Thanks a lot for having me on. This was like super fun to get a chat with you.
All right. Well, thanks for your time, Rich. I'll chat to you later.